decomposition in time series, you know that we have the components, the time series components, whereby we have, of course, the compositional components, that is trend, cycle, seasonality, and randomness. So one of the things that you want to understand is that for you to be able to do seasonal decomposition to such a data, you must tell SPSS that this is a time series data. Because if you go to analyze and then you go to forecast and then we have seasonal decomposition, this is the error message. Seasonal decomposition requires at least one periodic date component to be defined. So what you do, you go to data and then you define dates. And then when you define dates, remember our data is in terms of months. It's all the way January to December, and then it's from 2004. So it is years and months. This is what we want, and then we come from 2004 to 4, and then one from month one. That is month one is from January all the way to month 12. That's what we are doing, and then you click OK. So once you click OK like that, it has generated. So you go to our data here. So once you go here to your data, you see that we already have year, that is to 2004 all the way to 2006. Then we have the month, and then of course we see it is a seasonal, because we see the periodic is from 1 to 12, and then again it start again from 1 to 12. So here we have a time series data. So you go to analyze, and then we go to forecasting, and then we have seasonal decomposition. So of course we are trying to decompose sales data, and then we have the multiplicative and we have the additive. We know that in additive is whereby we usually say that the seasonal error or the seasonal fluctuation is similar, is dependent on the trend, and then we have the additive one. So it depends with what model that you're going to use, but for this case let us use multiplicative as the way it is. And then now that is it, and then you just click OK. So when you click OK, it tells you that there will be 4 variables of the data. So more variables that are going to be generated. So you just say click OK, so that we can now see the variables. So first of all, before this is the seasonal factor of the seasonal indices. So let us see the variables that have been created. So come to variable view. And our variable here, we have the error, that is the randomness. We have the seasonal adjusted series, and then we have the seasonal factors, which we have seen them there, and then we have the trend and the cycle. So when you go to so these are the seasonal factors which have already been generated here in terms of percentages. So if they're here in terms of percentages, one of the things that we want to see, how do we interpret this seasonal factor? So I like interpreting them in form of a graph. Let me just change this into a graph. Select all these, and then you right click, create a graph which is in line. So great. So we have a graph here. So let me add another reference line here. I'll put a reference line here at 100% because our reference is 100. I'll apply there, and then let me also add markers. And then these markers. So let me put them in terms of green, which is and the body is also green. Then I apply, close. So great. So come here, you'll see that at 1, this is the months, 1 all the way to 12 up to December. You'll see at 1, that is 120, which already have been given 120%. So it tells the normal, this is expected, the normal sales at 100%, the normal sales at 1 or at 100%. We'll say that in January, we expect 20% more than the normal sales. In February, that is 83. The seasonal factor of February is 83.9, and the 83.9, which is lower than 100. So we expect that around 16.1% lower compared to the normal sales. So that is how you interpret the seasonal factor. The other aspect of decomposition is now the error in terms of the randomness, or the error, the unpredictable randomness of the trend. So we can go to graph also, where we can use the line graph, then which is simple. It's an individual case. Then we come and define. So the thing here is the error. We want to see about the error. Let me put it in terms of case where now we can plot everything. And then just click OK. So when I click OK, so the same case here. So in the event that, let me add also, I'll still add the same way that we've added our, let me put green, I love green, and then another green. And then of course I'll put a reference line at 1 and just apply, and then I'll close it here. So look at the error. So you can see that all this time that you see at 1 there is no error. We found the expected sales that we want. But now you'll see that from 1, even if let me try to increase this graph. So you'll see at 1 there is an error, at 2 there was this type of error, there was this type of error. So you can see that these are the randomness that have been happening, or those that have been causing the randomness of our time series data. So that's how you get the randomness of which that is the error of the cells. So this is the random that has been extracted from the data. So the other thing that we can try to see is we can go back to the data. Where is our data here? So the other thing is the STC. This is the trend and the cycle. So those are the last two components of decomposition where we need to see also. So let's come to graphs. If you go to graph, still the line graph. So when you go to line graph, in this case, we have two data sets which I want us to, so multiple and then individual, yeah, which is okay. So the lines here, I want us to we have the trend which is there, and we have the sales, the original data, and then the case number, and then we just put it there. Now look, you see, the green one is the normal sales that we've been having. You see now there's a lot of randomness, there is seasonality, but now this one has now been decomposed and all those factors have been removed. So it tells us, first of all, you can see it is going downward. So there is and the long-term trend is that will be going downwards. So which is a negative. So at the end of the day, we are going to see that the sales of this company are going to go down. But what about the cycle? The cycle tells us the irregularity. So you can see here in year 1, let's say for example up to this 12 here, you can see the sales are going down and then they come up at around September, that is 9, and then that is all the way to December, and then in January, and then they start going low. So again you'll see that so that is how we get our cycle. So our cycle is that between from September all the way to January the following year, the sales are usually on an upward, and then they start going low. But the long-term trend is that these sales are going downward. So that's how to perform seasonal composition in time series that are using SPSS. Thank you.